Okay, let me start the recording. Good morning, students. This is KG Krishna from BITS Campus, Hyderabad Center. Uh, Today, we are going to discuss about Six Sigma. So, this is a special lecture in which I also requested our BITS Pilani Practice School interns also to participate. So, this particular topic of Six Sigma is relevant for everyone in the business. It is a generic concept of a process. How do you measure? How do you improve the productivity of a process? And how do we make ordinary people perform extraordinary deeds? Okay. Let us get started. I don't know how many of you have heard about this word Six Sigma, but during the last 20 years, this has gained prominence in industry as a method of improving the processes. Okay. There are various workshops and lectures and books on Six Sigma. While several of these lectures and books focus on mathematical aspect of Six Sigma, today we are going to focus on the soft aspects, the thinking aspects, the attitude of Six Sigma. Okay. More than mathematics, Six Sigma is a way of thinking analytically and tracking improvements in a process. I'm sorry, I just skipped the slide. So the topics for today's discussion is that in the first we try to understand what is a Six Sigma, and then take a little bit background of Six Sigma concept. Where did it originate and where are we now? And next talk about Six Sigma methodologies and tools and various roles and responsibilities in a Six Sigma project. And finally, how you can use Six Sigma in your own life, not only in your professional life, in work or business, but also in your personal life. Okay. I don't think today we can squeeze in all the topics. Maybe some of these topics, particularly that how you can use Six Sigma and how it impacts your personal and professional life, maybe we'll continue in the next session. So let us try to demystify the jargon. Okay. See, people say Six Sigma is a quality initiative for achieving world-class performance. That is just in English. Okay. And then when you hear the word Six Sigma, people try to ask what is Sigma so that we know what is Six Sigma. Okay. By the way, most of these slides are the visuals and the content of these slides are borrowed from net sources. So I have rightfully acknowledged the original authors. Okay. So what this Six Sigma thinking is all about? Okay. At a fundamental level, it is all about process orientation. Okay. So let me get my pen right here. It is all about process orientation. So what is a process? We'll see later. Thinking everything in terms of process, whatever activity, whatever endeavor you do in any organization, we have to think in terms of a process. Then about measurement. We know business is all about measurement. Business is all about management. There cannot be a management without measurement. Then about productivity. So, and defect reduction. Okay. How to reduce defects in a process. And then about methodology. How do we improve the productivity or reduce defects in a process using a structured methodology. And finally, the role of innovation in redesigning the process or re-engineering the process so that the opportunities for defects do not exist in the process. Okay. So that is all about philosophy. So these are the things we are going to focus today. But however, if you ask me what is a Six Sigma as a quiz, a mathematical definition, it is nothing but 3.4 defects per million opportunities for defects. Okay, that means if you have a million ways of things going wrong, in how many instances actually things went wrong or defects occurred. Okay, so that means if you have million ways of things going wrong, only 3.4 occurrences resulted in defects, then we can say this process is Six Sigma compliant. Learning about Six Sigma methodology inculcates thinking in terms of processes, metrics, and pursuit of excellence in ensuring defect-free delivery. Okay. By the way, the word defect-free is in Ethiopia. There is nothing like 100% defect-free or a zero defect. Okay. But reasonably, we can say that if your process capability is Six Sigma, that means 3.4 defects only occurs per million opportunities of defects, then we can reasonably say it is nearly zero defect or a defect free. Okay. Now let us talk about what is a process. The word we use very often, the word process. Okay. In my view, process is the one which makes ordinary people deliver extraordinary results. This is a very powerful statement. In fact, this is the one which has been used all over the world to characterize a process. It just simply explains the beauty of a process. Okay. For example, if you want to fix an automobile, or you wanted to assemble an engine, okay, at the outset, if you are not process oriented, you might think it's a very complex skilled activity. Okay, only a trained technician, a trained engineer can do, assemble an automobile. But if you are a process oriented thinker, just like Henry Ford was during his time when the Industrial Revolution started, during the time of automobile manufacturing, from the perspective of a Henry Ford, who was the pioneer in the concept of the process or assembly line, for him, that if we are able to break up that complex piece of activity into a set of steps, sequence of steps ordered in such a way that each of the step could be performed by an ordinary person standing near the assembly line. Okay. So instead of one skilled mechanic, okay, if I can train 100 operators, and each of the operator focused on a particular specific task of fixing a nut or fixing the wheel or painting something or tuning some particular engine, very specific activity, a micro activity. Okay. And each of these mechanics perform their job on the production line at a particular designated time and space in a particular order, then the whole machine could be assembled. So that was the dream, that was the great idea of assembly line, and in fact the assembly line further gave away to the concept of a process today. So that the concept of a process had its origin in manufacturing era. Now extend the same metaphor of assembly line to the process. Okay. Today we use the word process, okay, invoicing process, HR recruitment process, okay, Uh, uh, Practically for everything we suffix the word process. Transportation process, okay, reservation process, okay, recruitment process, okay. Similarly, the famous example which made Six Sigma famous, in fact, which branded Six Sigma is Mumbai Dabbawala's case study. Okay. All of you know this story of Mumbai Dabbawalas. Here, in this example of Mumbai Dabbawalas, okay, they are ordinary people. Okay, they are ordinary people who are focused on a particular task. Okay, and they do it repeatedly, day after day, with sincerity and devotion. But together, as a system, the whole process of transportation of tiffin carriers from home to office and then back from office to home is extraordinary. Okay. It looks very complex for someone from outside. Okay. It's a complex system of tiffin carrier transportation in a clogged, congested city like Mumbai. So it is mind-boggling. But at the core is the process in which ordinary people, okay, the workers, the dabbawalas, together as a teamwork, who are operating in a structured fashion without using any of the technologies. They did not have mobile phones and they did not have dedicated transport trucks or vehicles or GPS as we have today. And by the way, remember that this particular system of Mumbai Dabbawalas existed even before independence, since as a reading from the net, almost from 1890 onwards, okay, with impeccable accuracy and precision. Okay. So, as engineers, we are all engineers, as leaders, so our job is to create such processes so that ordinary people perform extraordinary results. Okay. This is what entrepreneurship is all about. Okay. So we have to assume the mantle of an architect, a designer of systems and processes, okay, which will enable simple-minded, ordinary people with limited education and skill together as a team can deliver extraordinary results. Today we can see this practice in new age entrepreneurship activities like e-commerce, okay, online taxi walas. Okay. These are all ordinary people, but as a complex system, leveraging the technology, leveraging the beauty of process definition, that they are contributing to India's economic development and employment, and of course the valuation, business, and the wealth generation. So let us understand a little bit more about what is a process. Okay. Let us try to demystify the jargon. Okay. As we said, we use this word quite often in conjunction with other words like the system, a method, methodology, framework, architecture, so on and so forth. Okay. Different words, we use it in different disciplines. Engineering, we use the word framework, architecture. In management, we use the word process, method, methodology, etc. etc. But there is a subtle difference in each of these words, which I'll try to explain it. Okay. So basically, at the outset, whenever you hear the word process, remember that the process is a structured sequence of activities when performed in a particular defined sequence converts some raw materials. For example, let's say you imagine process as something like a black box. Okay, you have raw materials, something is input to the process, right? And the process is delivering some output. Okay, so at the highest level, when you are looking at 30,000 feet level, you can look at the whole thing we can encapsulate it as a black box called a process. Okay, process. Okay. And it takes certain inputs. Inputs could be in terms of raw materials, in terms of technology, in terms of information. It could be anything. Anything could be inputs. It could be virtual inputs like information or raw materials or anything. Output is the desired results. Okay, it could be a product or it could be a service. Okay. So, process is not just for manufacturing of goods from raw materials to finished goods. It also could be delivering of services. This word is very generally used to describe not only manufacturing, not only chemical processes, not only manufacturing processes, not only assembly line processes, but also delivery of services. Okay. Even hospital management services and delivery of healthcare services, delivery of education. Okay, everything can. So at the highest level, it is just a black box. But if you expand this further, then we can say this box is as a stepwise refinement. So the first step is something to do A. Okay. Then it is sub process. Okay. Then the A will give some output which is input to the process B. Okay. Then so on and so forth. Then you have process C. Okay. Then you can have also a complex. This output could be output from A could be taken by D, and there could be another process which takes the input. Let us say this process is E. Okay. So this will give. Let's say this. The output of G is the final output. Okay. So this method of breakdown is called process refinement, also known as stepwise refinement. Stepwise refinement of process. Okay. Please note here we are starting from a high level macro view, okay, by encapsulating the complexity as a black box and unraveling that complexity in a step by step using a black box approach. Okay. See, for example, let's say that you want to manufacture an automobile, okay, and you don't know anything about automobile engineering. Okay, so then how do you start? Okay, say first you make one black box, which process P as manufacturing of automobile process. Input is raw material steel, output is car. Okay. It's as simple as that. Okay, nobody can deny that is not a process. That is a process. Okay, only thing is that you have not broken down the steps into manageable, refined sub processes. Okay, then someone who is more familiar with automobile manufacturing, he will further break down this macro level process into various sub processes. Okay. The sub process A could be like testing of raw materials. Okay. B could be engine. Okay. D could be a body. Okay. So this could be a body manufacturing. This could be engine manufacturing. E could be engine manufacturing. And together finally the block G could be quality control, which is testing the automobile before it comes out of the assembly line and into the warehouse. Okay, you see, so that is how, for example, even the next step is you can break down this A is again into sub process. So the level of refinement, stepwise refinement, can go to a level wherein that each of the activities in the box is something can be done by any ordinary worker on the shop floor. Okay. So now please reflect, okay, and this is what is engineering is all about. This is what system architects or a designer, okay, or entrepreneurs actually do as part of business design, as a part of organization design, or whatever it is, to deliver customer service. Okay. So now having understood what process is all about, okay, now let's look at another word called system. Okay, this is also a common word we sometimes confuse or misuse and think synonymous with the concept of a process. Okay, what is a system? Okay, see, unlike process, wherein the keyword is a structured and sequence of activities with some well-defined input and output, okay, a system doesn't have a input and output concept. Also, there is no sequence. Okay. A system is a interconnection. For example, let's say I'll just say system is interconnected elements. Elements could be again subsystems. Okay. The good example is transportation network, a railway transportation network, or a road transportation network, or airline transportation network, etc. See, if you try to imagine how airlines work, okay, there's nothing like input and output described. So airlines is a system of aircrafts, system of airports, system of passengers. All these three subsystems are related to each other. So in a system, everything is connected to everything. Okay, for example, if I take a simplified diagram of A, B, C, so A is connected to B, A is connected to C, and C is connected to B, as simple as that. So in engineers often call this as a networked system. Okay. Similarly, railway network, road transportation network. Okay. Here the beauty of the system is the system gives a behavior which cannot be deduced from the constituent behavior of the individual subsystems. Okay. For example, you take the example of a human body. Okay. Human body consists of several subsystems like nervous system, okay, which is related to thinking and about brain, okay, and the heart, which actually pumps the blood, the heart system, and about the structural system, which is bones, okay, and muscles. Okay. These are all the individual. Liver, digestive system. Okay. The liver, stomach, and intestine. These are all part of the digestive system. So these are all the subsystems in the biological human being system. Okay. Now, if you look at the behavior of a human being, the human being is a very complex system. Okay. So he can speak, he can talk, he can think, he can run, he does all the functions of a human being. But now we cannot deduce now his speech. For example, if he is delivering a speech, like for example I am delivering a lecture here, is it because of my mouth component or my vocal cords component, or is it due to brain, or is it due to my muscles? Which one is contributing? I cannot deduce the general behavior of the system to a set of one or two or three subsystems. So as a together, suppose let's say my legs are cut off, obviously I cannot speak. Then okay, my vocal cords are cut off. Probably I can try to use some other things and try to speak. So in a systemic sense, that the resultant behavior of the system is an outcome of an aggregated behavior of all the subsystems together. But how they generate that behavior is something which we cannot describe using a flow chart. Okay. See, all of you know you are a computer engineers. Okay, you cannot write a flow chart of human behavior in terms of inputs and outputs. Okay, so flow chart is same as a process. Okay? A process can be described as a flow chart, but certainly not the behavior of a human being, how a person's think, okay, how a person writes a technical paper, how a person uh, uh, does a particular activity. You cannot describe as a flow chart involving the human body parts, right? Just like the way an IC engine, delivers. Okay. So, for example, you look at the birds. You look at the birds. Okay. So birds fly into formation. Okay, a V formation on the sky. Okay. And that is a systemic output. So, but each bird performs its well designated function. We don't know what it is. It is still a magic how the birds fly in formation. What is the relationship between one bird to the other? Okay, there is implicit communication protocol among these birds. But together, when we look at the sky, we see the birds flying beautifully in a V formation. Okay. While each bird knows about its duty perfectly in relation to its bird ahead or bird at the rear. Okay. So that is the system. System is, we can say, the best way to describe a system is a network of components, network of subsystems, which together will generate a behavior which cannot be deduced from looking at individual parts. Okay. Then the word method. Okay. Generally, we use method is a way of doing things. For example, we say that a method of improvement, a process improvement. Okay. Six Sigma is a method. Okay. Six Sigma is one method of improving the process. Okay. It is a way. It is a technique. Okay. Whatever words we use, it is a general English vocabulary. Okay. Methodology is a more scientific vocabulary. Methodology. Okay. It's a way of doing it. So we say Six Sigma is a methodology for continuous improvement of a process. That's what we say. Okay. But otherwise, both are same. Method and methodology is frame. Okay. So framework and architecture is all about organization of elements. For example, if you look at a building architecture, okay, any construction building is arranged as a foundation. That's called substructure, then superstructure, then electrical things, all laid on the top of each other. Okay, as a layered architecture, we call it as. Okay. Similarly, a framework. Framework means it is a model. So another word we use is a model. Okay. So these are related words. For example, framework, architecture, model. These are all related, in which these words describe an organization of concepts in a particular order, arranged to describe a particular building or a model or etc. But whereas now you are clear now the difference. What is a process? Process is a structured set, a structured and sequence of activities when we perform, deliver results, translating inputs into outputs. Okay. Now there's another word we come across is project. Project. Okay. A project is actually an action. Okay, doing things. A project also is a sequence of activities, but here we more focus on a one-time activity. Okay. A project to build a dam. Okay. Okay. So, for example, a project to build a dam is a one kind of activity. You can say every dam construction is a unique experience. So here in project is basically about uniqueness. Every project is unique. Okay. Every experience of a project manager is unique because the challenges, the risks and the issues faced by the project manager are unique. That's why project management is a well-defined, well-respected role in any organization. Whereas process is a mechanical. For example, if you look at a BPO process, handling a call center process, okay, wherein an employee or a customer calls in the organization, and the employee who is handling the call is supposed to receive the call and service the customer. So there is a well structured process of how to handle customer complaints, how to handle customer requests, or how to handle transactions, etc. It's very well defined, documented like a flow chart. Okay. So that we can call as a process. But however, project involves lots of challenges, lots of unknowns. In process, the number of unknowns are are very minimal. Absolutely, there are not many unknowns because everything is documented, everything is specified, and to a large extent. That's why nowadays we say that if the process is so documented and so well defined, we can even relegate it to automated machines like robots or automated voice response systems. Nowadays we see that many of the service calls are handled by machines using IVR systems, automated voice response, saying that you have reached customer service, please press 1 to get into finance department, press 2, press HR department, and so on and so forth. Okay. Process can be automated, okay, but not project, okay, because project involves lots of challenges which requires the ingenuity of human beings, the project manager, to take decisions, to think innovatively, to respond to situations on demand, etc. Okay, so so I'm sure now you got some clarity of various words being used today. So our focus in this lecture is about process. Okay, just a minute. Okay. Now, so having said about process, let us look at the process of Mumbai Dabbawala. Okay. See, they may not have a documented process. Okay. See, this business of Dabbawala delivery has been there since ages. It is integral to their culture, maybe there in their mind. It may not be documented like in today's ISO 9000, CMMI compliant organizations, where everything we expect it to be documented and circulated and controlled. All the process need not be documented. So the best example is the process followed by Mumbai Dabbawalas. If you look at, okay, so if you want to describe, this is taken from I think Harvard case study paper on the Mumbai Dabbawalas. Okay, let's look at. Okay, so you can say that the first is a pickup process. So each of the Dabbawalas, okay, pick up the tiffin carriers from home, okay, and they collect, aggregate all these dabbas at one particular location. They put together, they put all these dabbas with some coding. We'll see that what is the coding followed later on, and then they they put on the station. They go to the station, okay, to Mumbai suburban railway station, and there is another person probably. He carries that whole tray or thing into the destination station, in various stations. So all these which are tagged, different trays go to different stations, right? At all these drop-off stations, again the corresponding dabbawalas pick up those trays and again they deliver to the final destination. You see, at each stage the people are different. Okay, the people are different, but the process is the same. So the person who collects your tiffin carrier at home may be different from the person who actually delivers to the recipient, okay, just like our postal system. Okay. But it's a well coordinated, well orchestrated with implicit coding system and with a perfect discipline, and it happens. It works. Okay. And remember, the beauty is, and the same process gets repeated. So in the evening, when the employees finish their lunch, okay, the empty dabbas are collected, and it again um, delivered back to the homes. Okay. See, you imagine this scenario now. Okay. How is this possible? How is this possible? Okay, they are illiterate. Okay, they can only read numbers and some codes. Okay, and so what the thing which makes it possible is, one, of course, is the coding. Okay, so they code each dabba in a particular system. This is a system which is described here, but it is for example, A is a pickup resident pickup station, because in Mumbai is all about local stations. This pickup station A, okay, and this is pickup station means it's a group of colonies or something. It is, while Parle is the station code, okay, the origin code, and destination pickup code, okay, destination group code, and E is its abbreviation maybe EX means Express Towers in Mumbai, Nariman Point, or wherever, and 12 is the 12th floor. See, I don't know exact the coding structure of this, but it is such a simple system. Okay. This every carrier, the Rabbawala, understands this implicit coding system and follows it rigorously to deliver the carriers to their intended destinations. Okay, but now try to imagine the complexity. See, there are so many stations, so many homes, and so many destination stations. It is not that many to one. Okay, it is not that collect tiffin carriers from entire Mumbai and deliver it to only Express Towers of Nariman Point. Okay, it is not many to one, or not one to many. It is many to many. Okay, many homes and many offices which are scattered throughout Mumbai. It is equivalent to, like I can say, a courier system. It is equivalent to our postal department. So as complex as that. And the beauty is it is 98% on-time delivery. Okay, I'm talking about on-time delivery, not delivering the wrong dabba to wrong place. Okay. And too many combinations. Now, if you try to imagine, there are number of ways in which things can go wrong here. Okay, maybe a wrong coding of the dabba. Okay, maybe the dabbawala delivering the dabba to a wrong destination, or late delivery. Okay, or totally missing, or the whole thing has fallen off the crate, and that whatever. And you look at the environment. Okay, in Mumbai is all monsoon, all the time, throughout the season, throughout the year is a rainy city. Okay, so these people have to wade through all the hurdles of Mumbai weather, and pull themselves up into suburban trains with it's crowded suburban trains, and you can imagine that there could be n number of ways things can go wrong in the system. Okay, there could be n number of ways defects can occur. Okay, but in spite of that, they deliver the dabbas without any defect. So that is the beauty. So now we are getting into the statistics part of it. Now we understood what is a process now, okay, by illustrating this dabbawala. So in case of course, here in this simple age-old process of more than 100 years old process, which everyone can relate to, here it is primarily driven by people and the culture and attitude. No technology is used. Okay, so we did not have barcode or RFID or mobile phone or a smartphone or GPS trackers or pickup trucks or whatever, okay, which we can afford it today. Okay. So here in this process model, people played a major role. Okay. Okay, and the people are 88% are illiterate. Okay, and there are 5,000 employees, the Dabbawalas. I don't know, this may be a very old one, maybe now it's because I picked up this slide from a net source. Okay, number of Dabbas is about 2 lakhs, that is about 44 lakhs transactions every day, two-way, right? You have to deliver to office and again return the Dabba back to home. Okay, and the average time taken is 3 hours. It's amazing. Okay, so what is so extraordinary? Okay, say we define the process is a magic which ensures ordinary people deliver extraordinary results, right? So now what is this extraordinary thing? Okay. Every working day they transport more than 1,30,000 lunch boxes throughout Mumbai, the world's fourth most populous city. The Tentiles conducting upwards of 260,000 transactions in 6 hours each day, 6 days a week, 52 days a year, but mistakes are extremely rare. Okay. There are semi-illiterate workers who can read just numbers. Okay. They achieved that level of performance at a very low cost in an eco-friendly way. Okay. They are not using any trucks, without use of any IT system or even cell phones. Okay. That is extraordinary. Okay. Now, what is the defect rate in this case, in this case study? Okay. 1 in 16 million. Okay, that means if there are, if you take a particular scenario of 1 week or 1 month or 1 day, okay, if in that period of study, if there are 16 million ways of things can go wrong, okay, things can go wrong means defects can occur. Okay, the defects could be defined as wrong Dabba delivering it to wrong person, or delivering it late, or Dabba being broken, or Dabba. It could be, you can define the defect the way you want it. So you can define, you can articulate the meaning of a defect. Okay, and then you can start counting the opportunities for defects. There are a number of opportunities for defects in every instance. Okay, so for example, if you take 100 Dabbas being collected, and each Dabba can have a defect related to late delivery, a defect related to broken Dabba, or defect related to wrong shipment. Okay, so each Dabba is associated with 3 defects. So the 3 defects can occur for any Dabba, right? So that means you have, if you take the example of 100 Dabbas, so 100 multiplied by 3, each Dabba together about 300 opportunities for defects exist in the system. 300 opportunities. Okay, out of 300 opportunities, how in reality in a day, okay, how many defects actually occur? So that is what is the talking about the sigma count, 6 sigma count. So in this case, in this case, we have found that the error rate or a defect rate is 1 in 16 million. Okay, you can translate that into a percentage. It is some 98.999 or something, which we will see later on. Okay. Okay. So now, having understood what is a process, and let's try to define what is a defect. Okay. See, we have a notion of a defect in relation to a physical object. Okay. For example, when you buy a car, there is a scratch. The engine is not starting. Okay. there is a broken window. Okay. We can easily quantify the defects, okay, for a particular physical product, not meeting the tolerance, not meeting this one. Okay. But if you take, for example, a service, you are delivering a service. Let us say delivering a railway ticket service. Okay, you pick up a phone and then order a railway ticket, and ticket has to be delivered to home. Okay, okay. There could be defects in the service, late delivery, or wrong ticket issued, or a spelling mistake in the name, or etc. All are defects. Okay, so basically, the first thing in the Six Sigma methodology is that having identified the process, you have to define the defect. What is a defect? A defect is undesired result, an unpleasant customer experience, or it could be a deviation from specifications in case of physical product. Okay. So this is important step in the Six Sigma methodology. That defining defects. What constitutes an undesired result, unhappy, pleasant experience. You have to list down precisely. Should not be any ambiguity. The idea here is you should be able to count the defects. So Six Sigma is all about counting. Okay, it's as simple as that. It's all about counting. It's not a magic. That means when you got trained in Six Sigma methodology, it doesn't mean that suddenly you got some great new brain and magic in your brain that you can come out with great processes. No, absolutely not. Six Sigma methodology is a way of looking at a process and counting the defects and tracking the productivity. That's it. Okay. Why defects occur? Defects are mostly due to badly designed or implemented processes. Okay. We know that the process leads to defects. So if the defects are occurring at the delivery, okay, that is due to bad process. Okay. So in this context, we also try to differentiate between quality control versus quality assurance. If you have not heard these words before, I am sure some of these practice school students may not have heard this word, and our SQM students are already exposed to this. Quality control is a stage gate process. So in quality control, we focus on checking the product at the time of at delivery time. At delivery to customer. Check at delivery. Okay. So let's take about automobile or pagers or phones or anything. So before the product is packaged and shipped to the customer, there is a quality control inspector and who looks at that one and he tests all the functionality and puts a QC stamp, QC, and then ships it. If the product doesn't meet the testing criteria or the stated specifications, the product, he puts a rejected stamp and goes into seconds or maybe recycling and all. So all the rejects in a way are a cost to the company. They're a waste. They're a loss to the company. Add to the cost of operations, cost of the process. In contrast, quality assurance is not about controlling at the or stage gating at the delivery side. It is more about looking inside the process. So quality assurance people ask always a question that if number of defects are increasing, okay, that means number of rejects at testing is increasing, there must be something wrong with the process. It is a process which is producing the bad products. So let us look into the process and try to minimize the defects by improving the process, maybe by looking at intermediate products and putting some checks and balances in the process itself, so that the outcome would be of high quality. The outcome would always be all the products of the process would be meeting customer satisfaction. So this is the whole concept of QC versus QA, and today most of the organizations emphasize QA. Okay. The culture of QC has gone. It is much before 1980s. Okay. and it had its origin. Six Sigma had its origin in manufacturing industry, okay. And it was Motorola. So all of you know it's a Motorola. It's, it's a global brand in electronics and communication equipment manufacturer. So they, in some time during mid 80s or late 80s, okay, so Motorola was in production of pagers. So do you know pager? Anyone knows pager? What is a pager? Pager is an electronic device which is a communication device. So in those days, in the late 80s or mid 80s, the concept of pagers was very popular. I don't know how many of you know about the pagers, but I do have one. I can show you here. It's a Motorola pager, which I bought in 1994, and this pager is a one-way communication device. Okay, sorry if I'm digressing this, but it's a very interesting insight. Okay. So pagers entered India much before cell phones, in 1994 and 95, that period. So if you want to send a message to someone, okay, then you can pick up the phone, landline phone, only landline phones were there at the time, and you dial a particular operator, a paging operator. He picks up the phone, asks what is the pager number. So you give a pager number of the person to whom you want to page. Then the operator asks what is the message. Okay, you say message is please call back, or please come home urgently, please report to the hospital, so and so. Okay, then the operator takes the message, like a call center operator, and then he types the message into the computer, and that company has a transmitting stations all across the city. So it beams the message, radio broadcast, and all the pagers receives that. So the only pager for which the code matches, the pager number matches, it decodes the message, and then it gives beep 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 beep. So when I look at the beep beep beep, then I press this button and see the message. Oh, this is a message from home. Please come home urgently. Okay, or report to the hospital immediately. I'll call back this number. Then immediately either I go to the nearest public booth and dial this number and get the message, or immediately rush to the hospital, etc. So doctors and these lawyers and stock brokers who need to be contacted on emergency basis, they used to have this pager. And by the way, this pager was very expensive in those days. It used to cost almost 8,000 rupees, almost half of the monthly salary of a software engineer. Okay, and per month subscription was about 400 rupees a month, unlimited messages. I can say, just flat rate of 400 rupees per month. Anyone can page any number of messages on demand. Okay, so when the Motorola was making these pagers, okay, they had several defects. Defects could be related to production, related to design, could be anything. So they constituted a committee to see that can we avoid rejects. So you see that the pager also has you have a QC stamp here. Okay, then you're not able to see that. I think remove the sticker. So there are many rejects. So they wanted to eliminate rejects, and they said they wanted to improve the process. How to improve the process on a continuing basis? So that was the historical background of the Six Sigma methodology, was pioneered at Motorola for improving the or reducing the defect rate in pager production by looking at the process. Okay. Then, so having identified the defects and analyzed the process where actually the defects are occurring, the next step in the Six Sigma methodology is mistake proofing the process. Okay, when you say the key word is mistake proofing, that means you have to redesign the process in such a way that there is no scope for defect, or in a way what it means is to reducing opportunities for defects. Okay, opportunities for defects. Okay. So naturally, when you reduce opportunities for defects by employing a technology, by employing some, or cutting down a long chain of activities, etc., you are in a way you are contributing to less number of defects. So when you reduce opportunities for defects, then the net number of defects actually automatically come down. So mistake proofing or redesigning the process, mistake proofing by redesign or re-engineer, redesign or re-engineer or innovate a new process. Okay. Say, take the same example of Mumbai Dabbawala. So, if you have identified one process, one defect where a Dabbawala reading the code on the tiffin carrier wrongly, because sometimes V or B can be read as 8 or S can be read as 5 because of our human idiosyncrasies. Okay, we are not as reliable as computers. So during the analysis of the process, we discovered that human reading of the code is error prone. There are many opportunities for defects because there are so many Dabbawalas are there. There are so many opportunities for reading the code wrongly. Okay. Let us automate it. Assuming hypothetical scenario, we put a barcode or a RFID tag to every Dabbawala and the code is read by a barcode reader. It's a technology intervention. So by incorporating such a technology intervention, we are reducing such opportunities for defects which was inherent in a human reading of the code. Okay. This is just an example. So there are so many examples. We can leverage technology, we can leverage training to reduce opportunities for defects. So in a way, mistake proofing the process. Okay. Okay. So let me, yeah. I'll take a break maybe in just a couple of minutes. And in Six Sigma methodology, the key thing is measuring. Okay. So we said Six Sigma is all about counting defects. Okay. So if you cannot measure, you cannot manage, and there is no Six Sigma methodology. So metrics orientation is the key to management and continuous improvement of the process. Okay. So everything should be measurable. So when you define a defect, the defect should be measurable, should be countable. Six Sigma is a quantitative measure of process deviation. Okay. So when you say quantitative measure is 3.4 defects per million opportunities. So why did we arrive at this 3.4? Why not 6.5 or 10.2? It is a statistical nicety. If you are a mathematician, maybe we'll share it some in our later slides. Okay, but for this moment, don't harp on why 3.4. It is as good as almost like 0, right? If you look at 3.4 in a million is almost approximately equal to 0. 0% defects. Okay, so we'll take a break here. So let's break here. If you have any questions, okay. If you have any questions, please do post now. Questions? Any ambiguity in the vocabulary? You should be able to relate these words to your real life. Okay. Today, everything around you revolves around process. Okay. Everything around this revolves around the process. Okay. So, defining a process is not so easy. You have to pay attention to detail. You should be able to write down, put your pen to paper and think like a computer engineer, like a software engineer. Write everything in a structured way. Don't leave anything to random chance. Okay. Write all the assumptions, write the flow chart, organize your thinking into a structured flow chart. That is what we call process centric thinking is all about. So it's not so easy. You can develop. Okay. Okay. So certainly we'll answer. Karthik, you have a question. In my organization, I hear about Six Sigma certified. Six Sigma Green Belt, yes, you are going to hear that in our subsequent later half of this lecture. Okay, don't worry. Let's take a break. So we'll be, let's, just 1 minute. Let's be back. Back at 7. Okay, just 5 minutes. So we'll restart at 7:20. So meanwhile, you can keep posting your questions. I think there is a question and answer window also is there. I don't know. Yeah, there is a question and answer menu button also is here. Either you can post on QA or in the chat box. No problem. Yeah, pass. Pass. Post them right away. I love to answer your questions rather than reading off the PPT. So this PPT is something which we can always read. It is available in your website, in your Takshila eLearn website. And also there is, if you go to Google and type Six Sigma, you will get at least 3 to 4 lakhs hits. Okay, there is so much of content, so many people have done projects and made presentations and studied this. So it's not a rocket science. It's not something you feel only this PPT is relevant and all. So you can read any material. Of course, most of the material is good, and people use different words, different examples. But my attempt here is to give you a bird's eye view and to make it very simple and to make it as a part of your thinking process rather than a complex topic to be mastered with for examination. Yeah, you will get the recording. Everyone, I will share the recording not only for SQM students but also all PS2 students as well. Yeah. Okay, so let's get started. Let me start the recording again. Okay. Welcome back. So let us summarize whatever we have discussed so far. And we said Six Sigma is a goal. Okay, it is a goal of 3.4 defects per million opportunities. Okay, to make in every process. So it is a set of tools and methods used to improve or design products, processes, and services. Okay, and services. It is a statistical measure. So people ask me, what is sigma? How did it arrive? So sigma is basically a statistical measure, standard deviation. How many standard deviations is away from the mean kind of thing. A disciplined fact-based approach. It is fact-based. It is metrics-based. It is a measurement-based. A means to promote greater awareness of customer needs, performance measurement, and business improvement. Okay. See, before the advent of Six Sigma, The only way the process gets improved is, when the customer starts complaining, and the CEO takes interest and he says that, please look into that and please fix it. So people used to fix in a piecemeal fashion. Okay, if they come to know that there is a problem in this particular machine, they used to fix it. But no one ever had an opportunity to look at the whole process in a holistic way, in a professional way, in a structured way. So Six Sigma actually, in fact, provided a structured methodology or a framework for process improvement and organized discipline. Now, those of you who are interested in mathematics, we try to understand what is a sigma measure. Basically, sigma. So this is a standard deviation. This is a normal distribution. So any random event. Okay. For example, let's say you have a dartboard and you have a target. Okay, you want to hit the target. Okay. So this is your desired goal. Okay. So you hit a target. You hit. Okay, at various levels or circles, right? How far? So let's say this is your desired mean. How far is the actual from the desired? Okay, 1 sigma or 2 sigma. So as we move away from the mean, the probability comes down. The probability of this one is very, very less. So most of the things will be around. Oh, sorry, I'm just. So most of the things are around. Oh, sorry, why it is skipping? Just is around the mean, right? As we move away from the mean, the probability of occurrence of these is very, very less. Okay, so this is 1 sigma. Spread of the data points around the mean. The farther you go away from the mean, the probability of occurrence is less and less and less. So because it's asymptotical, it never reaches 0. Okay, so because so the idea of Six Sigma is to reduce the variation. So you basically reduce the variation, make it very, very narrow. Okay. So if you define, let us say, Six Sigma limit is around the mean, 3 sigma is 6 sigma, is upper limit or lower limit. Here, so when you are a 6 sigma deviation, 6 standard deviations away from the mean, the probability of occurrence is 3.4 per million. So the probability is very less. So that means most of your desired things will fall within your. So basically your limits should be, our upper and lower limits should be within 6 sigma. If you are not following about it, don't worry. Okay. It's all about managing the variation. So you make the variation so narrow. Okay, so it's not widespread, narrow, and so if you look at this control chart, this is called control chart, QC control chart. Okay. This is upper limit, maybe lower limit. You can say here this is a defect and this is a defect, etc. This is also a kind of defect. This is a defect. Okay. So when you adopt a Six Sigma methodology and try to reduce the defects, so mostly is within, defects are after reduced within the limits. So of course it is not reality. Maybe there may be one, maybe there. Okay, but this occurrence of this is 1 in 3.4 per million. 3.4 defects per million. If this process is at 6 sigma level. Okay. So in a nutshell, Six Sigma is all about controlling variation or reducing defects per million opportunities. So different people use different way of expressing it. If you are in the manufacturing, making automobiles or parts with the tolerance levels, you can say is controlling variation. Okay. If you are in the business of service delivery and tracking defects, you can use the word defects per million opportunities, called DPMO. Okay. Okay. So why you are focusing on variation? Okay. So variation is that customers feel the reality. Customers don't feel the averages. Okay. See, mathematically you may have an average. Say there is nothing like average performance. Okay. So when you tell a customer that our average response time for delivery of an e-commerce shipment is 1 day, it doesn't mean anything for him. What he actually means for him is that out of how many packets, okay, are the packet is he receiving on time or not, okay. So that is what is important. So for mathematicians, average may be relevant because we are all in the analytical people. But for customers, whether it delivered on time or not, okay, even if it is 1 minute or 1 day or 1 hour late, it is a defect for them. Okay, so the idea here is that reduce such defects, narrow it down, the limits, so that 99.9998% of the time that the deliveries occur within the stipulated norms only. Okay, I think I have already explained is a structured framework for undertaking systematic and measurable process improvement. Okay. So here, reducing defects in end product or service is equivalent to same as eliminating opportunities for defects. So the whole thinking involved in Six Sigma is how do I eliminate the opportunities for defects? How do I improve the process so that the opportunities for defects do not exist at all? So sorry, this is not appearing, is actually Six Sigma. Okay. So the simple measure is Six Sigma is, so you want to compute your sigma, sorry, it is not Six Sigma, your sigma level. If this is 3.4, okay, if this is 3.4 defects per million opportunities, then you can say this is equivalent to Six Sigma. So how do you calculate defects per million? Number of actual defects observed, number of opportunities for defects that exist in the process. If this ratio is 3.4, then you can say Six Sigma. If it is more than that, it is lesser. It is maybe 4 or 5, and that we will see it is not a linear scale as something. Okay, we will see that in subsequent slides. Okay, so now let us try to get a feel of this number in reality, in real life. For example, let's say the process performance of a pizza delivery. Customers want their pizza delivered fast and guarantees 30 minutes or less. So this is